Assalamualaikum warahmatullahi wabarakatuh. So our group will present uh, our group project, which is IDP, the integration of project between subject PSC and electrical power level 3. So our group number is 16. So our group member is uh, Muhammad Ali Syahid bin Zairuddin, VJ anak lelaki Balasundrang, dan saya sendiri Muhammad Amir Fuan bin Azmi. So introduction to DOL. DOL also known as a direct online starter, which means motor is linked directly across its three-phase supply in a DOL starter. The motor draws a significant high inrush current compared to the motor full load current because the DOL starter links the motor directly to the main supply line, which usually up to 5 to 8 times higher. However, with this high inrush current, there are also protection mechanisms in the DOL motor starter, such as the circuit breaker or miniature circuit breaker and overload relay auto. So, which means when there is high high overload current, the auto will trip and the motor will be not started. So the mechanism of direct online starter, when we press the stop button, the current flowing through the contact and motor will started. So if we want to motor to be stopped, we just press the stop button and the current flowing to the contact stop, and as a result the supply to the motor is cut off. So usually DOL is used with small motors. A huge motor connected directly across a three-phase line would not function properly and would be damaged since it would not accelerate as quickly as a smaller motor due to its short axial length and larger diameter and more heavy rotor. So which means with big and huge motor is not suitable uh, with DOL because it will damage and it will run not smoothly. So introduction to the forward reverse. A forward reverse motor starter is built using two standard contactors that are installed with a mechanical interlock to prevent the simultaneous pulling in of both coils. The coils are outfitted with usually close contact, which are then coupled in a series with the coil for the opposite direction to the function as an electrical interlock. Uh, the function of interlock is to prevent accidental activation of both the forward and reverse coil at the same time, which means if we want to the motor run in forward direction, uh, the reverse coils will prevent the reverse coil from being energized. So introduction to PSC. PSC, small industry computer called programmable logic controllers, are used to automate specialized control procedures. The PSC took the place of the wired relay system, which was complicated and challenging to operate. So usually PSC are frequently used to control motors, pumps, lights, fans, circuit breakers, and other pieces of equipment in factories and industrial facilities. PSC substitute the conventional relay system, which is so much complicated and too much wiring. Uh, so with PSC, it become simpler. So one more thing, programming language is quite straightforward, unlike other computer language like C and C++. It does not require the usage of special tools. So this is a PSC CP1A trainer that we use. So the objective for IDP, students should able to analyze the PSC programming using different process description to control an automation system for various applications. Students should be able to categorize the fundamental of power system and motor control starter component based on theoretical. Students should be able to program, testing, and troubleshooting the error in PSC program by using CS programming software to solve the engineering problems. And lastly, the student should be able to conduct the experiment on several types of starting electrical machine and power system component. Okay. So the statement case study. Uh, First case study is about the DOS starter. So when the start button is pressed, the AC motor starts and remain on until the stop button is pressed. So that is the case study for the DOS starter. And the next one is about forward reverse starter. The first case study for forward reverse starter is when the forward button is pressed, the AC motor begins to rotate in the forward direction. The motor will rotate in the opposite direction when the left button is pressed. The start button will bring the motor to stop in either forward or reverse mode. The motor can be moved in either forward or reverse direction using an interlocking system. The motor will start to rotate in forward direction after 5 seconds of pressing the forward button. So the second case study is the motor will start to rotate in forward direction after 5 seconds of pressing the forward button, and it will start to rotate in reverse direction after 3 seconds of pressing the left button. The start button will bring the motor to stop in either forward or reverse mode. The motor can be moved in either forward or reverse direction using an interlocking system. So we'll pass the next part um, to our next presenter.
Assalamualaikum and selamat sejahtera. My name Muhammad Ali Syahid bin Zaruddin. My matric number AN 200097. So next is we look at for the experimental setup. So first is without the PLC. So without the PLC, we looking for the control circuit. So they have two control circuit: direct online starter DOL and forward reverse starter. So this is the connection that we have done on the board, and there are few equipment that we use like the circuit breaker 3-phase, circuit breaker single phase, contactor, push button, overload relay TOR, and signal lamp. Next, we look for the operation of the direct online starter and the forward reverse starter without a PLC. So first we connect the 3-phase power supply, red, yellow, blue, and we connect also ground and the neutral. Okay. On the all power supply and on the single phase circuit breaker to test the control circuit first. The push button start for the direct online starter is pressed, then the signal lamp will turn on. Okay. And when the push button stop, press the signal lamp will off. So after that is forward reverse starter. When the push button start, forward is pressed, the signal lamp for the forward will on.
Forward.
And when the push button reverse is pressed, nothing happen for the circuit, and then the push button stop is pressed, and the signal lamp of the forward will turn off. Okay, now for the when the push button start for the reverse is pressed, the signal lamp for the reverse will on.
Reverse.
And when we push the other button, there are nothing happen on the circuit. So now we continue for the motor circuit for the direct online. push button start, the motor is on. When the stop, push button stop is pressed, the motor will off. And for the forward reverse, push button forward is pressed, motor on, and when we push the another button, the motor will still on and nothing happen. Okay. After that, we push the forward reverse push button, and the rotation motor will turn for the opposite direction. Okay, then the push button stop is pressed and the motor will off. After that is with PLC. First is direct online starter. Using PLC that we use the PLC CPY threader kit, and we use the push button for the input. So in this while using the PLC, we use the relay. Okay, this is the direct online starter using PLC. So first, turn on all the power supply of 3-phase, and we test the control circuit first. Okay, the push button is pressed, button start press, and the signal will turn on, and the stop button is pressed, signal will off. Okay, next is the motor circuit. The push button start is pressed, the motor on, and push button stop is pressed, the motor will off. Okay, after that is the forward reverse starter with PLC. So it is same like the direct online starter, but we use 2 relay and 2 contactor, and 3 different output push button, forward push button, reverse push button, and the stop push button. So in this forward reverse starter, we have 2 case. For the case 1 is the normal, and the second case is using the timer. Okay, for the first case is normal for reverse starter. Connect the 3-phase power supply and on all the power supply switch. After that, we test the control circuit first. Forward push button is pressed, and the signal forward will on. And when we push the reverse push button, the signal still on and there nothing happen. Okay, after that, the push button stop is pressed and the signal for forward will turn off. Then forward push button, reverse push button is pressed and the signal lamp for the reverse will turn on. Same. And then we press the push button stop. Next, we test the motor circuit. So on the circuit breaker for the 3-phase, and start the button for the forward. Okay, then after that, push the stop button and press the reverse push button, and the motor will change the orientation in opposite. Okay, after that, we are the second case is using the timer for the push button. Okay, when the forward push button is pressed, the time delay for the 5 second and the motor will start on. Then stop, press the stop button
Stop. Okay. Reverse.
and
One,
press
two, three.
the reverse push button and the time delay is 3 seconds. After that, the motor will start on in the opposite
Okay.
uh, direction.
Forward, red.
Start button will press and the motor will off. And that's all from me. And I will pass to the my next group members. Thank you.
Hello, my name is Vijay Annaki Balasundram. My metric number is DN20021. The next part of presentation discussion will be presented by me. To make sure we meet the project goals, we create two types of motor connection, direct online motor connection and forward reverse motor connection using components like breakers, contactor, relays, push button and pilot lamp. In the meantime, safety is crucial when performing this task. For instance, we should exercise caution when installing the component to railing. This is so that we won't injure our end during installation. After that, for testing with motors, safety is essential. Handling the motor shouldn't be done with bare hands. When handling the motor, always use protective gear like gloves and make sure to stand on rubber mat. Additionally, we check to see that the PLC module is free of unwanted components like conductive waste. Next, we test both circuits with motor after we successfully attaching both motor connections to the wooden board. As we move forward with our project, the ladder diagram is built in CX programming. Afterwards, we move the software to a PLC because the lab does not have enough PLC unit. So our group used a PLC module for this project. Next, we simulate the ladder diagram and observe the result. Before converting the manual operation to a PLC program, we remove the stop and start buttons. Since we encounter various problems, we had to work hard to finish this project. While connecting the direct online motor, we first add some faulty connections that prevent the circuit from working. But as those issues were fixed, we were able to use the circuit to operate the motor without any issues. After the connection is complete for the forward and reverse circuit, we test the circuit and it fails. In order to get the outcome we needed, we had to replace the defective PLC module that caused the test to fail. For the last part of the project, we connect the forward and reverse connection with the timer. The ladder diagram is simply as the timer added. When the button is pressed, the PLC issues the command. A timer which was established using the ladder diagram and it will begin a few seconds after the button is pushed is also initiated. The motor will turn off when the stop button is pressed. We prefer the forward reverse motor connection compared to direct online connection due to the relatively low price. There are no limits to the number of times they can be operated. The components require very little space. The starting current is reduced by approximately one third. A device that controls the flow of electric power to a motor is designed to safely start and stop a motor and provide overload protection. A physical barrier that is pushed into the part of one coil armature by the movement of the coil in a forward-reverse motor starter, whereas tool does not reduce the starting current of the motor and unnecessary torque that support our decision to use forward reverse connection over direct online connection. Let me continue with my presentation. I will now present the conclusion portion of it. As an outcome, this project had a number of steps to complete before the output was obtained. Without any modification, a single motor was powered by a direct online starter, pushing a button to start the motor and another to stop it is all required to operate it. The forward-reverse connection comes next, consists of two more contactors, one for forward and another for reverse, while we just use one contactor for direct online starter. For forward and reverse, the direction of motor will often be affected by the connection. Each modification will have a time gap shown by the timer. The ladder diagram used to program the PLC eliminates the needs for timer, allowing the PLC to control the adjustments. PLC may simplify the process since it lightens the workload and increases productivity in terms of providing excellent results. We were able to comprehend the control circuit, control mechanism, and main circuit for the direct online starter and forward reverse connection. Using measuring instruments like multimeter and clamp meter, we can measure the speed of the line as well as the phase voltage and line current. We can also understand how an AC motor begins with using a doll or forward reverse starter. The objective of this project have therefore been accomplished. It concludes my groups and my own presentation. Thank you, Dr.